Hi guys, this is Miss Forness. We're going to do a continuation on absolute value inequalities. Now just to review, you guys remember that if you have the absolute value, right? So if I have the absolute value, when I solve for the absolute value, and if we're talking about an equation, just a regular equation where you have equals, then it's a negative number. So for instance, this is an example. If I have like the absolute value of x is equal to -3 and it's negative, this is no solution. Why is this no solution? Because the absolute value cannot equal a negative number because absolute value is a distance. It is a measure away from 0, and so the distance away from a number has to be positive. So that's why this doesn't make any sense. This is saying a distance is a -3, and that does not make sense. Now, it's different when we have inequalities. So for instance, if I get, these are the rules. If I have the absolute value of a function, right, and it is greater than a negative number, that's okay. The answer to this will be all real numbers. Versus, again, this is for inequalities, if you have the absolute value of a number and it's less than a negative number, this would be no solution. Why? Let's talk about it. So here, I'll give you an example. Here's my example. So if I tell you the absolute value of x is greater than -3, versus here I said the absolute value of x is less than -3. So this is greater than. Another way of looking at this is above. When we're talking about our y values, this is less than. This is talking about below for our y values. So let's look at this graphically. So if I was to draw a graph, x and y axis, right? And I had the left side, it was the absolute value. So parent function, absolute value, we have 0, 0, 1, 1, 2, 2, 1, 1, 2, 2. There's my graph, the absolute value of x. That's green. Y equals the absolute value of x. Now, let me go ahead and graph -3. So that's on the right side, right? So I have -3. So the graph y equals -3, I'm going to go down 3. So this will be in blue. So it's a horizontal line at -3. So this is y equals -3. Now these are some statements that we need to compare. We're comparing the absolute value and we're comparing -3. So here's the absolute value function. Here's the function y equals -3. So here it says the absolute value is greater than -3, or it's above -3. So I'm going to look at here. It says the absolute value. Where is the absolute value function greater or above the line y equals -3? So here's the line y equals -3. What part of the absolute value graph is bigger than that or above that? And that is everything. Do you see that? Forever. Everything is above that line. So that's why this solution right here is all real numbers. And then for this guy right here, it says, same graph, right? We're still comparing the absolute value of x and -3. So it's asking, where is the absolute value now less than -3? Or where is the absolute value below the line -3? So what part of my graph of the absolute value is below y equals -3? Well, if you look below y equals -3, there's nothing there, right? Because the absolute value is above it, it's not below it. So this is no solution. So the symbol for that is a 0 or a circle with a slash in it. So those are the scenarios that you have with inequalities when you get a negative number to the right side. Remember, this is after you've gotten the absolute value by itself, right? You still have to use PEMDAS to get the absolute value by itself, and then you're comparing. So in conclusion, if it's greater than a negative number, it's all real numbers. If it's less than a negative number, it's no solution. If you're just solving with a basic equal sign, right, you have absolute value equals a negative number, that is no solution as well.